Hi guys. Let's continue the topic or the lecture for constraint. So this time we're going to discuss the second part of the first set of constraint, which is aside from continue with the lecture of point orient constraint, which we're going to use to set up a controller for a joint for this arm. So I prepared a arm model, which is a very basic arm model, and then maybe a non-renderable cube as a controller. So I already named it as a controller and then as an arm. Okay, so we're going to use this to control multiple functions or multiple actions on our hand. Okay, like we're going to use this to move the hand, we're going to use this as a controller for the rotation of the wrist and so on. Okay, so aside from constraint, point, orient, and maybe parent, okay, we're also going to discuss how to use aim and pull vector for constraint. Okay, so aside from this also, I'm going to introduce to you skeleton on how to create skeleton or joint. Okay, but the more detailed introduction for this joint, we'll have a separate video lecture for that. Okay, so let's start. Again, I renamed my cube, okay, as a controller, and then since currently I have parameters here or value here, which is translate x and y has value, we don't want any value to our controller, so make sure that it's in default settings like 00x and 00 translate and 00 rotate and 1 for scale. Okay, so to do that, make sure you go to freeze transformation. Just in case, if you want to make sure that your center for this controller cube is at the very center of its world or the object mode, or just make sure to go to center to pivot. Okay, now that we're ready, let's create a skeleton. So you go to skeleton, create joint, and then on my front view, because my arms model is or on the side of an object, okay, it's not raised, okay, and the palm is not facing down but rather it's facing on the side. So let's create a shoulder joint, and then elbow joint, and then wrist joint. Okay, I can just continue create a skeleton or a joint for the hand. However, we're not going to do that. Okay, this is an option that you can use. Enter this to end the creation, and then you go back to skeleton, create joint, and then maybe on my side view, orthographic side view. Okay, let me create a joint for the hand. Okay, and then let me check on my side view, other views, if my joint is properly created. It seems like I did it the wrong way. Am I? Let me go to orthographic front view. So this is the front view. I think I did it the wrong way. So let me go through my side view again. should do it the other way around. So click here, and then here, and then here. Okay, so let's check. There you go. Okay, so make sure that it's inside. So let's go back to front view. Alright, and then move this inside our mesh. I can also maybe move this the rotation. Okay, once we're set, once we're okay, currently the hand joint is separate from the arm joint. Okay, so it's not following. Now if you want to make it as one skeletal setup for the arm, just select the first joint on your hand, and then shift select on the wrist joint, and then you hit P or parent. Okay, and as you can see, upon parenting the hand joint with the wrist joint, it created another skeleton. Okay, again, for a much detailed introduction to skeleton, please check out the next video. Okay, so now that we're set, let's try to test if this is going to work. So this is some kind of a forward kinematics, or it doesn't have IK handles, and you have to animate your object or your skeleton according to the construction of your joints. Okay, so one by one you have to construct this. So if you're going to create an FK, you have to put a controller for each joint, and this joint you're going to set up a controller on rotation and translation. Okay, you don't need to put constraint scale because you're not going to attempt to scale the skeleton. Anyway, it doesn't matter if your skeleton is small or big, but during animation you wouldn't be able to see that, and even on rendering you wouldn't able to see the skeleton. So it's useless to scale it up or down. Okay, but for this demo we're going to do inverse kinematics or IK. So I'm going to create a IK handle. So to do that IK handles thingy, just go to skeleton, create IK handles. So a while ago we started creating a joint from the shoulder, elbow to the wrist. When adding IK handles, you do it in reverse, but you don't need to click on the middle area, which is the elbow. So just click on the wrist, and then no need to shift select. Okay, just click on the shoulder joint. Okay, now that you have IK handles, so let's select the IK handles, which is it's a line. Okay, at the very end of the IK handles, which is this one, it's like an arrow thing. Okay, and then if you move this, as you can see, it's moving, the elbow is moving along with the wrist. Okay, now for IK handles, if I try to rotate the IK handles, it doesn't have any effect on your joint because it doesn't control the rotation nor the scaling of the joint. It only controls the translation of the joint. Okay, so now it's hard to manipulate or control or animate this. Once we're done with the rigging, it's hard to animate a IK handles wherein, let's say you have too many characters in a scene, and then of course you have IK handles for each arm of your character. So if you're going to animate the IK handles, you have to zoom in to choose or select the IK handles and then set an animation key for it. Okay, so what we do in 3D is we add controller. Instead of animating the actual IK handles or the joint, you're going to attach this joint and IK handles to a non-renderable curve and make it as a controller of these nodes, which are the skeleton or joint and IK handles. So to do that, okay, like I said from the previous video lecture, the controller and the controllee has to be at the same center or location. If we're going to create or control the object in terms of translation, then the two, which is the controller and the controllee, has to be in the same point or same center. Okay, their center has to be exactly at the same location. So instead of guessing and then zooming in, let's say I'll guess that the center of the IK handles is here. But to double check, I have to zoom in. But when I zoom in, I have to move it manually, and then I have to check it again if I was able to place it correctly. So instead of doing this, let's just make the center of this controller same as the center of the IK handles. You don't do it the other way around. You do not make the IK handles follow the center of your controller, but instead make the controller follow the center of the IK handles. Otherwise, you lose the default or the default position of your joint. Okay, so how to do it? Again, you have to select the IK handles first. We're going to take the center of these IK handles, okay, and then make the cube adapt to this center, or attach or snap to this center. So shift select on the cube and then constraint, okay, constraint point. So right now the constraint point made the back snap to the center of the IK handles. Now they are having the same center. So if I select the IK handles, as you can see, this is the y-axis and this is the x-axis, and possibly the z-axis is pointing towards us. So if I try to select the cube, it's the same. The x is on the side, the y is up, and then the z is pointing towards us. Now, the problem here, since we selected first the IK handles, it made our IK handles control our controller, which is the cube, which is we don't want. Okay, we want our box to control the IK handles. So let me undo that. Okay, repeat the same process wherein you have to select first the controller and then shift select on the controllee. Okay, and then let's remove target. Just watch out this, okay, once I remove target, it automatically clears up the translate x, y, and z of the cube or the controller. Okay, now let's do it the other way around. So select the controller, okay, and then shift select on the IK handles and then constraint point. Okay, it doesn't have to move because they're already at the same center. Okay, so now every time I select on my cube controller and make it move, as you can see, the joint is already following my controller, which is the cube controller. Okay, however, if we want our wrist or our hand to rotate, Okay, the IK handles doesn't handle that type of controlling. Okay, again, the IK handles only controls the translation or the movement of the joint. Okay, it doesn't controls the rotation. So who controls the rotation? Okay, not the IK handles, but instead the joint. So if I try to rotate this joint, it will automatically follows the succeeding joint. Okay, so how do I go about that? Okay, I want this controller, okay, to control the joint. Okay, maybe I can control the joint here, or maybe I can control the joint here. Okay, but since I want the wrist doesn't rotate, or this area of the wrist doesn't rotate, okay, but rather the joint that has to rotate is the one near the hand area. Okay, so this one, this joint. Okay, now let's try. So I'm going to select the cube controller, and let me check first the rotate X, Y, and Z axis. So the X is going up, the Y is going sideways. So if I try to click on my joint, the X is going sideways and the Y is going up. Wait, so let me check again. Okay, do you think they're in the same type of rotation? I don't think so. So let me make the orientation of the rotation of the controller cube the same as the rotation axis of the wrist. So first, select the joint, because we want the joint center, okay, adapt by the rotation of our cube controller. So shift select, constraint, orient. So as you can see, it slightly rotated. Okay, now if we try to select the cube, this is the X and this is the Y. Now let's try to select the skeleton. So this is the X, this is the Y. So they have now the same rotation X, Y, Z together. So we can now set the rotation. However, since we first selected the skeleton, again, this time it is the skeleton or the joint that controls the controller box. Okay, we want it the other way around. So what we're going to do is we're going to select the joint and then shift select on the controller box and then remove target. Now let's do it reverse, because we want that the controller box controls the rotation of the wrist joint. So shift select on the wrist joint and then orient. Okay, now every time I translate, the cube, okay, the hand or the arm translate as well. Okay, now every time I rotate, okay, the hand rotate as well. Okay, so this is how you're going to make one controller, how to create one controller with multiple functionality or multiple effect to our skeleton or to our joint. Okay, now that we already achieved, or we're done with the setting up the translate and rotate. Now let's try to make the skeleton, okay, a bone for this mesh. Currently, this joint doesn't have any effect on the skin or the mesh. So what we're going to do is we're going to bind skin this mesh to our skeleton joint. Okay, so select the mesh, shift select on the joint, and then you go to skin, bind skin. Okay, now that we already binded skin, as you can see, the joint already changes the colors. So color coded joint. The highest one is orange, and then it turned into yellow, and then green, and then yellow, green, bluish, and then blue. Okay, now if I try to translate, okay, as you can see, I'm translating my cube, and as you can see, the arm is bending now. Now, once I bend the arm, the hand now looks awkward. That's why we can just rotate it, okay, and position it the way we wanted it to be. Okay? So, there are times when you attach the mesh to a rig and then you started animating it, the arms will look awkward. Okay, there are times that where it's going to twist inside the somewhere in front of the chest. It will twist awkwardly. Okay, in front of the character chest, or possibly it will tilt or flip. Okay, the other way around. Okay, so if we want to have a control to our arm or leg twisting, we can also apply this to legs. Okay, we can add constraint pull vector. Okay, so let me save that first, just in case we lost power, since it's kind of stormy. So arm, and then let me save it on my local computer. Anyway, arm. Okay, that, and then since save as, continue. Alright, now that let's start. Since we have a controller, how come my joint went too far from the skin? That's kind of weird. Anyway, we'll fix it later. Okay, now let's try pull vector, but we need a controller for the pull vector. Okay, let me duplicate the controller and then make it 0 0. Okay, and then 0. Now it's back to the default position. Usually on pull vector, we try to scale the upper part so as to create somehow like a pyramid shape. Okay, and then you move a little farther. Okay, okay, so this is the controller. Okay, and then we select the shoulder, or sorry, we select the IK. Let's try the shoulder first. Okay, so we would know what's the difference between trying the pull vector on the shoulder. So pull vector, okay, it created an error. It says that target joint 1 is not valid as a target to be type. Okay, it says it has to be in IK handles. Okay, so I did it purposely so that you would know which, if you, just in case you did it incorrectly. Okay, so it says it has to be attached on the IK handle. So I'm going to select the pyramid, which is the controller for the pull vector, shift select on the IK handle, and then pull vector. Okay, so the reason why it has to be attached on the pull on the IK handles, it reads up whether the IK or the reed is bending awkwardly. So how come I lost the skin bind? So let me do it again. Okay, skin bind skin. Again, if I try to translate this, okay, now as you can see, as I translate it, it's a little awkward. This elbow is going inward. Okay, now to control the inward and outward action of the arm, which is again, you can do it on the legs, just select this pole vector and then you can move. Okay, so you can properly place the elbow area using the pole vector. Again, the pole vector constraint should be on an IK handle and not on the joint. Okay, so let me undo that. Okay, and then this time let's use the aim, or let's try the aim constraint aim. So let me have here a spear which I want to represent as an eyeball. Okay, so and then I'm going to duplicate this as an eyeball. Okay, now let's try to duplicate this. Control D, and then put it somewhere in front of the two eyeballs. Okay, maybe we can make it a little further. Okay, and then while selected, select on the eyeballs and then constrain aim. Okay, as you can see, one of the eyeball flip. Okay, let's try it again. Let's undo it. Undo. Okay, let me do it one by one. Okay, select the controller, shift select on the controller, which is one of the eyeball, and then aim. So what happened? It flips up. Why? If we try to select the pole vector, the y-axis is facing up, the z-axis, x-axis is facing sideways. So just the same as this one. Okay, since this one, okay, rotated, I rotated it on x-axis. Okay, it tends to flip up the spear so as they have the same orientation. Okay, now let me select this eyeball. This time let me modify freeze transformation to make the translate 0 and rotate 0 and scale to 1. Now let's try it again. Shift select on the eyeball and aim. So what happened? It went on the other side. Okay, let's try again. Modify freeze transformation for both, and then select constraint aim. Okay, that's kind of weird. It's going inward. Now let's try if it's going to work. Okay, supposedly, there you go. Supposedly, every time this controller moves, the eye will follow. Okay, even on this axis, as you can see here from this view, every time I make the controller near, okay, the eye also moves. If I try to move my controller sideways, the eyeball, the supposedly eyeball, will follow. Okay, this is a constraint that we use for eyeball. Okay, it follows the direction, or it looks up the direction of the controller. That's why it's an aim constraint. Okay, so I think that's it for this video. We have completed the first part of constraint, and I were able to tell you which part of skeleton or rigging you can use this part, and this is the reason why I discuss in detail the first part of the constraint. So for the next video, I'm going to introduce to you skeleton, and then also another video will be I will tackle more of the second part of constraint. Okay, so that's it. Try to play around with it and try at your own pace. So watch out for the next video.